Hello, this is Mr. Craig, and this is day 14 of stoichiometry, which relates to limiting reactants. Now, I know that back in General Chem, you were all taught how to do limiting reactants. Unfortunately, a lot of you were taught the incorrect way to go about, or the procedure to determine limiting reactants. The way the AP exam wants you to find limiting reactants is to determine the limiting reactant by comparing the other reactant or reactants in the equation. We don't want to find out how much product is produced and then go back and say, oh, well, that one only produced this amount of product, that one produced that much product. We don't want to do that. We want to strictly look at just the reactants to determine who will run out first. In other words, once we run out of a reactant, the reaction's done. Okay, that's hence the name, limiting reactants, because like in our first problem where it says determine the limiting reactant when 55 grams of methane reacts with 22 grams of oxygen in a combustion reaction, and that's all it's asking. It's not asking you to calculate how much water is produced or how much carbon dioxide is produced, and we don't want to go about solving the problem in that manner. Okay, so when you're doing or working out limiting reactant problems, you need to do it in this format. Because some of the questions on the AP exam will just be this. In other words, it'll look just like this, except the names and the characters will change, of course. But the graders of the AP exam want to see if you can determine the limiting reactant without calculating how much of a product is produced. All right, so let's go about doing this equation. This is a stoichiometry problem, hence the title here. So stoichiometry here. So the first step we want to do is write a balanced equation. So we are given 55 grams of methane. So we'll write that down. And again, let's write what we know above it. So we have 55 grams of methane is reacting with 22 grams of oxygen. Okay. And then it doesn't even tell us what the products are. But you should know, because we need to know what the products are for step one, which is writing a balanced equation. So we know we have a hydrocarbon, which is carbon with hydrogen, reacting with oxygen. So that is always going to produce carbon dioxide and water, the same products you are currently breathing out. All right, so step one, is this balanced? I don't know. Let's see. All right, so I've got one carbon, 4 hydrogens, 2 hydrogens. So we'll put a 2 in front, and that is an even value in front of the water, so that's a good start. So we have the same number of carbons and hydrogens on both sides, so let's balance the oxygen. We have 2 oxygen here and 2 more there. So we have a total of 4 oxygens on both sides. All right, so step one is completed. Step two wants us to take what's given and convert it into moles. However, this is a limiting reactant problem. So we are given 2 amounts here. So what should you do? Well, it's a simple process. You pick one. You pick one of the reactants. And it doesn't matter if it looks like it's going to be an easy one or a hard one or difficult. You pick one. Because what you're going to do is you're going to compare it to the other. So, in this case here, and I'll show both examples here. Okay, so if I don't pick the one that you want to pick, I'll work it out. But you only need to show one equation for the limiting reactant. You don't need to find out how much carbon dioxide is produced by each of these 2 reactant amounts and then say, oh, well, that produced a fewer amount of carbon dioxide moles or whatever. You don't need to do that. You don't want to do that, especially on the AP exam, when it's just asking for you to determine the limiting reactant. Okay, so let's go ahead and do that. All right, so pick one. And I'm going to start off with methane since it's written first. Doesn't mean it's a limiting reactant, but I'm going to start with that one. So step 2 is to change what's given. So I've got 55 grams of methane, and I need to convert that to moles. So in 1 mole of methane, we have 1 carbon, which has a mass of 12.01, and 4 hydrogens, which is 1.008. And again, we don't want to round any of this. So we'll type that in, so 12.01, and I'm using my calculator here on the side. I'm tired of using that online calculator, it's just too slow. So 16.042, and we do not want to round anything until the very last step. All right, so that is step 2. If we were to stop right there, it tells how many moles of methane we have. Step 3 is we need to get rid of the moles of methane and compare it to the other reactant. So we need to go to moles of oxygen. So we'll use our mole ratio here. So moles of methane over moles of oxygen. And the whole point of balancing the equation in step 1 is so we can use those coefficients in step 3. So I have 2 in front of the oxygen and a 1 in front of the methane. All right, so if we were to stop right there, we'd have how many moles of oxygen? Now, step 4 is kind of a funny step, because in this problem it doesn't come out and tell you what we need to convert that unit to. In other words, moles of oxygen need to be converted to what? Well, we should always go back to the question and see what the other reactants units happen to be. So in this case here, it's given in grams. So we need to convert the moles of oxygen to grams of oxygen, so we can compare the grams that would be needed to completely combust all the methane to the amount that's given here. So we'll do that. So we'll take our 1 mole of oxygen, and since there's 2 oxygens and each oxygen weighs 16 grams, has a molar mass of 32 grams. So we'll type all that in. And again, I still have that 16.042 in my calculator, so I'm going to use that. So 55 times 2 times 32 divided by answer. So that gives me 219, roughly. Okay. All right, so let's talk about what that value means. All right. If I were to combust or completely use all 55 grams of my methane, if I were to use all 55 grams of my methane, I would need at least 219 grams of oxygen. At least. Do I have that much oxygen? I do not. I only have 22 grams. So, who is my limiting reactant if it requires 219 grams to completely use up all the methane? Well, I don't have 219 grams of oxygen. I only have 22. So that means that my oxygen is my limiting reactant. Okay? Does everybody see that? All right, let's pretend, and again, you're done with this problem. You've determined who the limiting reactant is. However, some of you may not be happy and say, well, I wanted to pick oxygen. And it doesn't matter if you picked oxygen. Well, let's go ahead and work it out if you did pick oxygen. Okay, so I'm going to erase that. Come on, you can erase. Actually, I'm just going to rewrite it here. Okay? All right, it'll be quicker to do it that way. So I had 1 methane plus 2 oxygen yields 1 carbon dioxide and 2 waters. Okay? And I had 22 grams of that and 55 grams of that. Okay. So let's use a scenario, and you would not need to do this second step if you pick the methane. You already have the question answered. However, I just want to show you and actually talk you through it if you happen to pick the oxygen, which we know is the limiting reactant because we worked out the first problem. All right, so step 1, write a balanced equation. We have that. Okay. Oh, come on, what is going on here? All right, so step 1, write out the balanced equation. We have that. Step 2, take what you're given and convert it to moles. So 1 mole of oxygen, which we said was 32 grams. And again, if we stop there, we'd have our moles of our oxygen. We want to use our mole ratio. And we're going to compare reactant to reactant. Okay, so from our balanced equation, we have 2 oxygens and 1 methane. And then in 1 mole of methane, that molar mass was 16.042 grams. Now this will give a different value, so I need to type this in. So 22 times divided by 32 times, oops, sorry, 22 times so 5.51. Where'd you go? All right, so here we go. And this is methane. Okay? So, let's say that you started with the oxygen, which is okay. Okay? So here's how you're going to talk your way through this problem. If I were to use all 22 grams of oxygen, if I were to use all that oxygen completely, I would need at least 5.51 grams of methane. I have more methane than I need. That means I'm going to have extra methane when I completely use up all of my oxygen. Therefore, my oxygen is the limiting reactant. Again, if I use or burn all of my oxygen, I would only need 5.51 grams of the methane to completely consume all the oxygen. Since I'm using all the oxygen and I have leftover methane, almost 49 grams of it, 49.5 grams of it. That is my excess. Methane is excess. It's extra. So when you see excess on the question, that's what it means. You have leftovers. This is my limiting reactant. Okay? All right, I hope that helped. And if you need to listen to that again, I would highly recommend that you rewind the first part of this video and listen to that again, because it's really important that you know how to do limiting reactants by only comparing the reactants. All right, let's look at question number 2 here. Okay, very similar. You have calcium metal and nitrogen gas will react to produce calcium nitride. Okay, so I'm giving you the product here. Calculate the mass of the calcium nitride that can be produced from the reaction of 75 grams of calcium and 25 grams of nitrogen. So the first part says determine the limiting reactant. Even if it doesn't say determine the limiting reactant, you from this point on will see 2 reactant amounts and you'll say to yourself, I need to determine the limiting reactant. And you'll do that. All right, so step 1, write a balanced equation. So we have calcium metal and we have 75 grams of that. So I'm just going to write how much we have. And we have nitrogen gas and we have 25 grams of that. And that forms calcium nitride. Okay, so we'll eventually find out how much of this is produced. So it wants to eventually calculate the mass. We're not doing that right now. We're simply doing A, which is determine the limiting reactant. All right, so we have to balance the formulas first. Calcium's good, nitrogen's good. Again, nitrogen with the gen ending means that it's diatomic. All right, calcium has a +2 charge. Nitrogen's a -3. So that means we need 2 of those and 3 of those. Okay? Erase those little charges. Okay, so I need 3 calcium. And my nitrogens look pretty darn good there. Okay? Alright, so. Now, some of you might be thinking, if I look at that and I do 3 divided by 75, that gives me 25. So there's no limiting reactant. They're both equal. Don't fall for that trap. I designed this question on purpose so that you try to fall for that trap. All right, so let's find out why that's not true. Again, molar mass. The molar masses are different. Okay, so let's start with the calcium since it's right there. So 75 grams of calcium. Step 1, we have our balanced equation written. Step 2, let's change what's given to moles, and calcium has a molar mass of 40.08, which is right here. So 40.08. So we barely have a little over, almost 2 moles of it. That's okay. All right, so we're going to stop right there. That's how much calcium we have. Mole ratio, so moles of calcium compared to moles of nitrogen. Okay, so we have a 3-to-1 ratio. Okay, now we need to go back to the unit that the thing that we're comparing to is in. So nitrogen is in the units of grams. So we need to go convert it to grams. So 1 mole of nitrogen. And again, nitrogen has a molar mass of 14.01. And so 2 of those gives you 28.02 grams. Okay, so let's do the calculation here. So 75 times 28.02 divided by, open up your parentheses, 40.08 times 3, close your parentheses, and it gives me about 17.5 grams, 17.47, but we'll go 17.5. Okay, and that is grams of nitrogen. All right, so let's look at this. Who's my limiting reactant? Is it my calcium or is it my nitrogen? Okay, and again, I highly recommend that you talk yourself through this. If I were to use all 75 grams of calcium, I would need at least 17.5 grams of nitrogen. How much nitrogen do I have? I have more than I need. So my nitrogen is in excess. So that means calcium is my limiting reactant. Okay? Calcium is my limiting reactant. Again, if I were to use all 75 grams of calcium, I would only need 17.5 grams of nitrogen. I have 25. That's more than I need. If you were to work it out where you started with the nitrogen, I guarantee you the value that you would find for the nitrogen or for the calcium would be a lot less than the 75. Okay? So that means that it'd be much, much more, my bad. Because to use all this nitrogen, you would need, I can do a real quick calculation, 25 divided by 17.5 times, so you need about 107 grams. Now, you don't need to know that. You don't have to worry about that. But do realize that we have extra nitrogen and all the calcium is consumed. Therefore, the calcium is the limiting reactant. All right. Now, the next part, calculate the mass of the product produced based on your limiting reactant. Okay, so now that we know who the limiting reactant is, we can ignore the 25 grams of nitrogen. Do not try to do anything with that 25 grams of nitrogen in this next step. Do not. So we have our 75 grams of calcium. That's how much we're going to start with. So we have our balanced equation. So we have 75 grams of calcium. You've already written the balanced equation right up here. You don't need to rewrite that. Okay? You have it once. You're done. Okay? So now what we need to do is change our grams of calcium into moles of calcium. Very, very similar to what we did in the limiting reactant problem. And again, the molar mass is 40.08. Okay, we're going to use our mole ratio. So we want to get rid of the moles of calcium. And we're looking for moles of calcium nitride. Okay. So from my balanced equation, we have 3 moles of calcium and 1 mole of calcium nitride. So a 1 and a 3 go there. Okay. And it wants to calculate the mass. So an easy mass to go to is grams. That's the values that are on your periodic table. So I would highly recommend you do that, unless you want to go to kilograms, milligrams, nanograms, picograms, whatever. It's your call. Mass, you get to pick. But moles is not mass. Okay? All right, so in 1 mole of calcium nitride, let's find out what that is. So from the periodic table, again, calcium's 40.08, nitrogen's 14.01. So we have 3 calciums, so let's do 3 times 40.08 plus 2 times 14.01, and that gives me a molar mass of 148.26 grams. Okay, so this will tell me how much of the calcium nitride's produced. So I have that number in my calculator, so let's not retype it. So we'll do that. Just hit times, and it should be answer. So answer times 75, and all the rest are ones. Hit divided, open your parentheses, 40.08 times 3, close your parentheses, equals, and it's about 92.5, 92.47. So 92.5 grams of calcium nitride. All right. Okay. All right. Part C. Finally, calculate the mass of the unreacted reactant. Calculate the mass of the unreacted reactant. All right, so luckily we did our calculation with the limiting reactant that we started with. We know that the nitrogen is our excess, and we know how much of the excess that we actually used, which is pretty cool, okay? So we don't have to do this step again. If you did not start with the limiting reactant and you had a question like Part C, you would need to show all of this, okay? You would need to show the limiting reactant starting off and then how much of the excess you're actually consuming. There's actually another way, but I'm not going to tell you that one just yet. All right, so since we know that we're using 17.5 grams of nitrogen, how much did we start with? 25. So we started with 25 grams of nitrogen, and we used, was it 17.5? Yeah, 17.5, roughly. 17.5 grams. How much is left over? Well, 25 minus 17.5. 7.5 grams. Okay. So that is how much of the unreacted reactant we used. Now, do you want to know the other way to do this in case you didn't start with the limiting reactant and you only had 2 reactants? Well, conservation of mass says what? That mass is neither created nor destroyed. Okay, so here's our scenario. Let's pretend that for some reason we started with the nitrogen here. Okay, we started with the nitrogen, and we calculated how much of the calcium was going to be consumed here, which would be all of it. Actually, it'd be, I think we said 107 grams of it. Okay, well, we know that the limiting reactant is going to totally go into making our product. And since there's only one product, this makes it very, very easy. If there was more than one product, you're going to have to show this step. But since we only have one product, all the mass of the reactants that are being used are going into forming that. So we know we have at least 75 grams of the 92. Okay, so we have 92.5 grams of our one product, and we used at least 75 grams from the calcium. So if we do 92.5 minus 75, that gives me 17.5 grams. Well, what does that 17.5 grams represent? My limiting reactant, or my excess that was used up. Okay? So if you want to use that method, that's one way. However, the only way you can do that is if you have one product. Okay? All right, well, I think that's all the questions for the examples. And again, I can't emphasize enough. Make sure that you know how to do limiting reactants without calculating the amount of the product. Okay? All right, as always, I hope this video has helped. And if you have any questions, please do not hesitate to ask.